Our project is designing a fertilizer runoff filtration system. Our supervisor is Professor Valerie Ward. Our project looks to address the problem of algal blooms happening in the waterways of Ontario and Canada. These blooms are caused by excess nitrates and phosphates found in the waterways, and a large source of these nitrates and phosphates is farmland runoff when fertilizers are overused and rainwater washes it off into creeks and streams, which lead into lakes. When these nitrates reach the lakes, they allow the blooming of algae. This algae has been blooming increasingly strongly over the past years, with an intensity of 34% higher in 2024 than the previous 5-year peak. This is a problem that's continuing to get worse as we use more and more fertilizer. These algal blooms can cause degradation of water quality and damage the surrounding ecosystems. Along with this can impact the livelihood of people surrounding these waterways. It can affect beaches, tourism, and it can also affect fisheries as fish are impacted by these blooms. Our solution is the design of a polymer-based filter which can be placed into the waterways near farmlands where runoff occurs. Part of the idea of this design is to be less invasive than something like a full-sized water treatment plant or a dam might be. Our design will allow fish to pass around the filter without being impeded. This filter is going to be designed using a polymer or a polymer bead called chitosan polyethylene glutaraldehyde composite, which is a composite polymer that allows both the absorption of nitrates and phosphates. The benefits we anticipate from this design is a significant reduction in algal blooms, which has benefits to fishery, tourism, and local ecosystems as described in the negative effects of algal blooms. We expect a minimal impact on the wildlife during operation because of the less intrusive design of the filter. We anticipate 10 regeneration cycles for the polymer at the very least, which means that the filter can be taken out, regenerated, and reused after it becomes saturated with nitrates. And we expect very minimal manpower dependence during its life cycle. It can be operated by just placing it in and allowing it to work.